Hello there, programmers, and welcome to another episode in our PyGame tutorial series. Today what we're going to do is we're going to build a classic puzzle game called Breakout, or Arkanoid, depending on what system you played it on. And we're going to get started off pretty quick. We're going to dive into this. There's a lot to cover, so let's jump straight into it and start working. Okay, so the very first thing you're going to need to do is go to kenny.nl, and you can search this in Google, search Kenney, and then look for the puzzle pack. These are going to be the sprites we're going to use for today. So we're not drawing everything ourselves today. We're going to be using sprites, and we're going to be building our project out with a structure that's a little bit more what we would build for a real game, as opposed to what we've traditionally done in these tutorials, which is just put everything into a single file, okay? So the first step, let's go ahead and grab the puzzle pack, go hit download. Kenny has a ton of resources on here, all kinds of asset packs that are fantastic. So if you feel like donating for him, please do so. This guy releases these all for free. I like to use them in my tutorials, so if you can just throw him a few bucks, he would love it. I would love it. It would help him make more assets, and I'll be able to keep using them for future tutorials. Once you download the pack, you'll unzip it, and you'll see the file structure is pretty straightforward. There's going to be a preview file in here. You can open the original AI file and modify these as you need to, and then you can see an SWF here. So if you have Flash installed, you can open it and actually look at the graphics that way. But what we're interested in here is the PNG directory, okay? There's a whole lot of assets in here. There are tons of things for us to use, but the only things we're really going to care about are the colored rectangles, the ball, and the paddle, okay? So grab your favorite colors of these. I like to grab all of the rectangles, so each rectangle of each color, we're going to be using that. And then we're going to set up a project directory. Start up a virtual environment inside of there. I hope you know how to do that. I use PyCharm to set it all up for me, so I don't have to worry about it, but go ahead and install your virtual environment for your Breakout project. Then what we're going to do is we're going to create a new directory in here, and this is going to be our assets, okay? And what I'm going to do is I'm going to just copy these from somewhere else. I have them over on another window here, and I'll show you which ones I copied, but you'll be able to see it. Yep, copy everything in here. So I'm using the blue ball, I'm using all of the different colors of rectangles, and the red paddle. And then I also, from Kenny.nl, I downloaded his font pack, Kenny Fonts, and I'm using the future font just because it looks a little bit nicer than the default system font. That's up to you if you want to do that or not. I'll show you how to import it and use it as part of this tutorial series, though, so if you want to go grab it, do so. Okay, great, that's wonderful. Now, let's go ahead and set up our project. So the first thing we're going to do is we're going to install Pygame, okay? Very first thing we do anytime we get a project set up, we install everything that we need. And then we're going to create our main entry point. This is going to be super simple file, okay? All this file is going to be doing is setting up the main game loop, and then instantiating our game class, okay? So we're going to break this up quite a bit. In previous tutorials, we've put everything into this main.py. Today, we're going to do things a little bit differently. So let's close this assets directory, and let's create another directory in here. And this other directory, we're just going to call it game, okay? And inside of game, we're going to create a new Python file, and we're going to set dunder_init.py, okay? So these are the two basic files we're going to start with. First, we're going to, inside of dunder_init, we're going to, we'll eventually import everything in here, but for now, all we're going to do is we're going to say class game, and then we're going to set up a couple of methods here that we'll be calling, okay? And we'll just pass on them right now. So we're going to do a handle events, and we're going to pass. We're going to do an update function, and we'll pass on it. And then a draw function, and we'll pass on it. Oops, too many S's. Okay. So this is our basic game class. We'll have these three functions in here. We'll be able to handle all input events. We'll be able to update any assets that we need to before we draw them, and then we'll actually draw them. So inside of our main.py, we're going to say from game import game. Okay, so we'll import that class we just created. And then we'll do an if dunder name equals dunder main. And inside of here, we'll set up the game object. We'll instantiate it. And then we'll run our game loop. So we're going to run forever on this game loop until an exit event fires, and then we'll call exit from inside the event handler. Okay? So all we need to do, each cycle that we run through the game loop, we'll call game.handleEvents first. We'll handle any events that have happened. We'll update any assets based off of the events that have fired. And then we'll draw them. And that's it. That's all we have to do here. So this class is done. This file is done. You can close this. You don't have to come back to it after we get this up and running. So if we hit run now, this will just run indefinitely. Nothing actually happens because we don't have any of our Pygame logic happening in here. Okay. So let's go ahead and stop this. All right. So we interrupted everything, but that's fine. Now we can come in and actually start to define what's happening inside of our game. Okay? So as I said, you can close main.py. We won't need to open it and modify it anymore. This is the basic structure of being able to pass everything off to our game module. Okay? Inside of our game, this is where things are going to start to get really interesting here. So first thing we're going to do is we're going to import Pygame. Okay? Let's also import sys. And then we're going to have in here, we're going to bring in game components. Okay, so this block here is going to be all of our interesting game components themselves. Okay, so inside of the game class, we're going to create our dunder init, and the very first thing we're going to do is set up Pygame. Okay. In a Pygame project, you have to call Pygame init for it to know, instantiate all of the internal workings of SDL, which it's built on top of. All right. So this init function is setting up Pygame itself. The next thing we're going to do is we're going to allow exiting from our application. Okay. So the way we can do that is we can set up a basic loop inside of the handle events every time that's called. And what we'll say is for event in pygame.event.get. And then this will grab all events off of the event. Oops, I misspelled event. This will grab all events off of the event loop that have been fired since the last call of handle event. And then we're going to check if event.type is equal to pygame.quit. We'll handle this. We'll call pygame.quit. And we'll call sys.exit. Okay? So this will cleanly exit our program for us. All right? And this says this can be static because all we're doing right now is calling the main event handler, the event queue, and pulling anything off of it that we can. Okay? But we will be doing class-specific actions in here shortly, but for now, this is all you need to know. Okay, so if we run now, nothing will happen, right? We stand up, we instantiate Pygame, everything, no windows show up, right? So when we hit stop, we'll see everything interrupts exactly like it did. In order for this to fire properly, we need to send the actual quit event, and to do that, we need a window. Now, we're going to create another file here. What I'm going to do is I'm going to set up a new Python file, and I'm going to call this constants, okay? And this is going to hold all of the core static values for everything inside of our project. It's going to be pretty simple. I'll go ahead and set up everything eventually, but for now, we only need 2 constants inside of this file to be able to spin up a window. So we're going to call this class constants, and then we're going to set up inside of here a screen height, And let's set that to 600. We'll have a 600 tall screen and a screen width equal to 800. Okay? And so now we have a constants file. We have a screen height, screen width. Inside of our game class, now we're going to be able, after we call Pygame init, we'll be able to say self.screen, and we'll set up our screen object. And the way we do that is we say pygame.display.set_mode, and then we're going to pass in the size as constants. Oops. Oh, before we use it, we should probably import it, huh? From game.constants, import the constants class. There we go. All right, so this is the module name. So it's game.constants, and it's the constants object. So now we can say constants dot screen width and constants dot screen height, right? So there we go. Now we've set up a there's an equal sign in there. So screen equals pygame.display.setMode, and we've set up our width and height for our screen. We'll call self.clock equals pygame.time.clock. So we'll set up our timer so that we can see how much time has happened in between each window. Okay? Now, before we go and actually start drawing this and showing things to the screen, let's set up a couple of other things that we're going to need that we won't need to touch again after this. So at this point, we're going to set up our background color. So the color that is going to be used to clear the screen and draw a new layer. And we'll do something pretty simple. We'll just do color, and we'll set it to black. Okay? So we're going to do pygame.color. We're going to set that as the background color. The other thing we can do here now is set up the font we're going to use to draw to the screen. Now, as I showed you, I pulled in kennyfuture.ttf. That's going to be the font I'm going to use, and that's inside the assets directory. So how do we actually bring that in? Self.font equals pygame.font and then we're going to instantiate the font class, and we'll use assets / KENNEY underscore FUTURE.ttf. There you go. And let's set this to 16 pixels. That's going to be our height. Okay. So now we've instantiated a font. We've instantiated background colors. I think that's all we need for now to get this up and displaying. So let's go ahead and actually draw things to the screen so that we have everything drawing like we're supposed to. Okay. So here in the draw function, what we'll do is we'll say, instead of pass, we'll do self.screen.fill self.bg color. There we go. So we will, this is the step that will clear all the graphics that were on the screen the last scene and fill the screen with whatever the background color is. In this case, black. Okay. So aside from that, there's not a whole lot more that we need to draw at this point. We will start adding all of our actual assets here shortly, but for now, if we hit play, we should now see a window pop up with a black screen. Pretty simple. All right. Now when we hit exit, everything exits properly because we have this event handler, we have the screen set up, we have fonts loaded. All of this is set up now properly. All right, now let's start drawing things. This is where it gets a little bit fun. So the first thing we're going to draw is we're going to create our player, our paddle, right? And this is going to be the thing that moves along the bottom of the screen that catches the ball and bounces it upwards, okay? So what we can do is over here, we can set up a new class. So we'll do a new Python file, and we will call this Python file player, okay? Inside a player, we only need to bring in two things. We're going to bring in Pygame, okay? And then we're going to bring in our constants. And that's all we really need in here. It's a pretty standalone class, okay? So we're going to say class player, and this is going to inherit from the Pygame sprites, okay? This will allow us to easily display an image onto our screen, load it in, show it like it's supposed to show. Okay. And so that the sprite class will handle all of that logic for us as long as we give it an image to draw and a size and a position. So let's go ahead and set all that up. Def dunder init, and then we'll call super dunder init. What this will do is this sets up the actual sprite logic itself, everything that we need to use. Then we can bring in our image, okay? So we'll set our self.image, and we'll set that equal to pygame.image.load, and we'll pass in the file name of the image we're going to load. So I have asset/paddle red.png. I wanted the red paddle, so that's the one I picked. I believe there's other colors. I think there's red and orange or something like that. I don't know. I can go look. What colors are there? Oh no, just red and blue. Okay, so you pick red or blue. Whatever color you pick, make sure you use that here. And then we're going to do a convert alpha. This optimizes the image for Pygame, makes it easier for it to draw, and sets the alpha transparency. So if you look at this image itself, you can see that it's a rounded image, but the image itself is square, so it's 96 by 90, or it's 104 by 24. So there are additional edges around here. If you don't set convert alpha, you'll get black all the way around the image in the full shape, in the full size of whatever the dimensions are here. Okay, and we don't want that. We want it to be see-through. So converting alpha is what makes it see-through. Then we need to set up the rect. This is how we actually tell Pygame where to draw things on the screen. And we'll do that by self.image.getRect. So we'll take this image we loaded, and we'll get the rectangle of that image, and that's where it's gonna, and that's how Pygame is gonna know where to draw this thing. Then we need to set a Y position. This is where we want to draw everything, and we'll pull that. The default, the starting Y position is going to come from constants screen height, and we'll set it 50 pixels from the bottom of the screen. You can play around with this number. I like it 50 pixels up. It gives you a little bit of space underneath the paddle for you to watch the ball fall to its death and make you very sad. So, and then we'll do self.x position, and we'll set this to halfway across the screen. And the way we do that is we say constants.screen width divided by 2. Okay. Then we need to set the rectangle to those positions we just set. And so we set self.rect.center equal to a tuple with self.x position and self.y position. Now we're keeping these separate. We're not using the rect itself to store all of these positions, so that we can do some easy math on the x and y position as we move things around. It makes it just a little bit easier, and then all we have to do when we draw everything is just make sure we set the rectangle center every time we update. Okay, you'll see that in just a second. There's going to be an additional little variable here that might not make complete sense, but it will when we get to actually controlling the ball. We're going to set the direction that the paddle has moved. Okay, the last direction it moved in is going to determine its impact on the ball itself. So it will either speed up or slow down the ball based off of what direction the paddle is moving. Okay, this adds a little bit of additional play value to the game itself. All right. And then the last thing we're going to do is set up the number of lives we have. Okay, so we're going to say self.lives, and for now we'll set it to 0, just because I want to put a number in here. But what I'm going to actually do is I'm going to go into constants here, and I'm going to set up a starting lives block, and I'm going to set that, let's say 3 lives. Okay, so we'll have 3 lives. We're not going to do anything with this yet, but what this will allow us to do is, if I come back in here to player, I can say constants.starting lives, and now it's set to whatever value is set in the constants file. Okay. We'll eventually lose lives, but for now, this is just going to be a placeholder for that logic when we get to adding it. Okay. Now that we've finished our initialization, that's everything that we need to set up in here. the next thing we need to do is set up our update. Okay. And so we'll set up our update with self, and we'll say there's a couple of things we can do in here. Let's see. Right. Okay, so if self.exposition. Okay. If the center of our piece, if we look here at our paddle, we can see that it is 104 pixels wide by 24 pixels tall. Okay. What we're interested in here is this 104 pixels wide. What we're gonna do is we're gonna make sure that when we move, we can't move off the left or right side of the screen. And the way to do that is to take our center position, which is our X represented by X position. Make sure that's not past the left edge plus half of this value. So we're at the halfway point. So half of 104 is 52. Okay, so this number might look hard-coded here, but it isn't. This is coming directly from the size of the sprite we're loading in. So if our X position is less than 52, that means we're on the left side and we've moved left. What we're going to do is we're going to reset ourselves back to that halfway point. We're going to stay at the left edge. And we can do the same thing for the right edge. If self.exposition is greater than constants.screen width minus 52. Okay, so we're going to take the full width minus 52. If we're beyond that point, we want to set self.exposition equal to constants.screen width minus 52. So to that number we just checked. We don't want to move past that point on either side. Hopefully that makes sense. Once you actually see this running, you'll go, oh, yeah, I get that. And then the only other thing we're going to need to do is self.rect.center. We're going to reset this to whatever the X position and the Y position are. So we can now start to adjust X position, Y position in other methods. We can adjust them here if we've moved past the edge. And we'll always reset the center of the drawing rectangle to whatever these values are. Okay, we'll do that on every update cycle. Okie dokie. So what else can we add in here? Well, let's add a lose life. Okay, we set up lives here. We set up, and now we need the ability to lose lives. Okay, we're not going to call this just yet, but if this happens, all we need to do is say our lives minus equals 1. Okay? That's pretty simple. And then if we run out of lives, we're going to get a game over eventually, and we'll want to reset everything back to play the game again. Oops. So let's go ahead and create a reset function just so that we have that as well. Okay? And we're going to set self.lives equal to constants.starting lives again. Okay? Those two we're not going to use just yet, but they're going to be very helpful later on. Then, what else can a player do? We can lose lives, we can start over, we can move, we can update ourselves, but how do we actually move? All right, let's go ahead and create two functions here. We're going to call a move left and a move right. Okay, so move left, how do we move left? Well, we move left to X position minus equals some number. What are we going to minus equal? Let's set 0 here so that we don't get an error message here. So our X position minus equals something. Let's go ahead in our constants file here and set our speed. How fast can we move? So we're going to set a paddle speed, and let's pick a number. Let's say 4 pixels. You can move 4 pixels per frame. All right, that's pretty fast. That seems fast enough. Let's do that. Paddle speed 4. So what we're going to do here is inside of this player, we're just, instead of saying 0, we'll say constants.paddle speed. Okay, so there we go. So our X position minus equals 4. All right. The other thing we're going to do here is we're going to keep track of the direction we're moving. So we've moved left. We're going to say our direction is equal to -1. Okay. So we're saying we're moving in the left direction. We're moving in the -1 direction. So that's how we know there. Okay. So let's go ahead and do the same thing in reverse. Self.xPosition plus equals constants.paddle speed. Okay? And then we'll set our direction the other direction. Self.direction equals 1. All right, so we're moving to the right. -1 to the left, +1 to the right. So now we have a way of tracking what direction are we moving and updating the x position of the paddle as we move left or move right. Okay, I think that's everything we need to do here in this player class. So we won't need to do anything else. We don't need to touch this anymore. This should be absolutely everything this actual player object needs to keep track of. So let's actually bring it in. All right, how about that? So what we're going to do up here at the top is we're going to say from game.player, import player. Okay, and we can instantiate the player up here inside of our init function. After we've set up our font, we'll say self.player equals a new player object. Okay, so this allows us to create the player, but we need to draw it. And what is the best way to draw sprites? Using sprite groups so that everything gets drawn at the same time. We're going to say all of our sprites are going to get drawn. So self.allSprites equals pygame.sprite.group. There we go. So we're going to set up a new sprite group, and let's go ahead and add our sprite, our new player sprite, self.player. There we go. So we've added it. So now we've created a player, and we've added it to the sprite group. Okay. And now we're going to need to update our player based off of keys that have been pressed. Okay. So we could, inside of this event loop, we could say if the event type is key presses, what key was pressed, and all of that. But there's a slightly easier way of doing that. There's a convenience function here we can use. We can say keys equals pygame.key.getPressed. So that's a convenience function to grab all the keys that are being pressed right now. Okay? And then we can just do simple ifs. So if we have a key press, and let's say pygame.k left. So if we're pressing the left key, the left arrow, then all we have to do is call self.player.move left. And if keys pygame.k right. There we go. So if the right key is pressed, we'll do the opposite. Self.player.move right. Yeah, that's all you need there. Okay, so you have a left key and a right key. Simple enough. So far, nothing too complicated here. So on the chance of updating, what are we going to need to do here? Are we actually going to need to do? Well, yeah, we are going to need to do something here. We're going to need to call self.allSprites.update. That'll just take care of it for us. And then to actually update all the drawing, all the displays, everything we need, we're going to say display pygame.display.update and self.clock.tick. How much do we want to tick? How about 120 milliseconds? Okay, that gives us a pretty good frame rate. And so there we go. So we're going to have all of that for updates. And then for our draw function, what we'll do is we'll say self.allSprites.draw, and we'll pass in self.screen. That's what we're drawing on. And that's it. That's all we need to do. So now we have a sprite. This player object is an extension of sprite. We've created a sprite group and added our player to it. We're checking for key presses, and if a key press happens, we're going to update the player, move them left and right. we're going to call the update function on all sprites, which, if you recall, our update function in here is just checking to make sure we're not off the left or right side of the screen. So we move the player first, we check to see if they're moving off the left or right. If they are, we set them back, and then set the center to wherever that needs to be. And the final step we're going to do is draw everything. Okay, let's run it. Let's see what it looks like. So when we run this, we now have our sprite. We have our red paddle at the bottom here. If I press the left and right key, look at that. I move. I hit the edge of the screen. I'm holding to the right, and I'm not moving past it. I hold to the left. I'm not moving past it, you know. Left and right work just exactly as we expect them to. And we can't move up and down. Nothing else happens here. Well, this is pretty boring. Let's make this an actual game. Let's add a ball. All right. The ball is going to be slightly more complicated because the ball is going to be the thing that's doing quite a few of our collision detections, and it's going to be bouncing around the screen. All right. So let's get started on that then. So over here on our game, in our game module, we're going to create a new ball.py, and we're going to start importing things. So first thing we're going to do is we're going to set up importing PyGame, and then we're going to need random from random import rand_int. So I'll show you what we're going to use that for in just a moment. We're going to determine a random starting direction using rand_int. Okay. And then from game.constants, let's go ahead and bring in our constants. Okay. Then we'll set up ball, and ball will again be a sprite. And let's go ahead and start defining this. Dunder init, and we'll call super dunder init. So we'll set up the base sprite, and then we'll start setting our position. So we're going to start in the dead center of the screen. So we'll set our X position, just like with our paddle. We're going to use a separate X and Y position so that we can do updates outside of the draw loop and have it show up in the appropriate place. Okay. So X position is going to equal to constants.screen width divided by 2, and self.y position is going to be the same thing, but for the screen height divided by 2. So there we go. We're going to start in the dead center of the screen. Then we need to load our asset. So I have the blue ball is the one I'm using. So self.image is going to be pygame.image.load, and the file name is going to be assets/ball_blue.png. And then we're going to do the same thing here with our convert alpha. So make sure we use the alpha conversions. Then we're going to set our rect that we use to actually draw to self.image.getRect. And then we need to set up a velocity. So the velocity is going to be the vector direction that the ball moves in. And so we'll set this up as an array instead of a tuple. So we'll say velocity equals and an array. We'll do a random integer, and we'll set this from 2 to 4. So we're going to move in the x direction from 2 to 4. Okay. So it always starts moving in the same direction as far as the x is concerned. And then the other thing we can do is rand_int. Oops. If I could spell rand_int, that would be great. And we're going to either go up or down or anywhere in between. Okay. So there we go. That's it. Then we're going to set our center. And this needs to be a tuple. Okay. And there we go. That's everything we need to do to initialize our ball. So we'll have a couple of things in here. We'll have the update. We're going to pass for now. We'll do a reset just like we did with the ball. Oops. We'll pass on that as well. We'll have, do we even need a draw? I don't even know if we need a draw. No, we don't, because this will handle the drawing for us. Are we going to need anything else in here? We will need some collisions and stuff, but let's go ahead and delete this for now. We don't need to worry about the collisions, the collision checks right now. Okay, we will do that in just a moment. The first collisions we're going to worry about are with the walls. Okay, so the way where we're going to do that is we're going to do that inside the update function. So we'll say if self.xPosition is less than 11. Now, why 11? Because of the size of the asset that we're using here. We're using the blue ball. If you look at the size of this guy, it's 22 by 22. So it's 11 pixels is the halfway point. All right, so if the x position is less than 11, so the center is closer to the left side of the screen, or x position is greater than constants dot screen width minus 11. So if the ball is on either side of the screen, so if it's on the left side or the right side, all we're going to do is set self.velocity of 0, which is the x velocity, is going to equal negative self.velocity of 0. So we're going to set it in the opposite direction. We're going to bounce it in the opposite direction. If it hits the left side, it's going to go right. If it hits the right side, it's going to go left. And then we need to check for the top of the screen. So if self.y position is less than 11, so the top of the screen is 0, if you recall, we're going to set self.velocity of 1 equal to negative self.velocity of 1. Okay. And yeah, what else could we have happen here? Oh, this is fun. So this random integer here, we can possibly set the y value to 0. And then we're going to be changing our x velocity as we move around. We're going to change it to the left, to the right, and it could also reach 0. So what are we going to do if it reaches 0? Well, we need to say if self.velocity of 0 is 0, we want to say self.velocity of 0 plus equals 1. So increase it by 1, just to make sure if we ever reach 0, we don't want it to go straight, because if it goes straight, it's never going to change direction. So let's bump it one way or the other. Okay. And if self.velocity of 1 is equal to 0, we'll do the same thing. Self.velocity of 1 plus equals 1. Okay. So let's make sure we don't ever hit 0 in the x or y direction, so that we're always moving at an angle. Okay, now that we've determined velocities, the other thing we need to do inside of the update function is we need to apply that velocity to the current position. And that's as simple as saying self.xPosition plus equals self.velocity of 0. So our x velocity. And self.yPosition plus equals self.velocity of the y position. So there we go. If we're moving in the x or the y, there we go. Now we're going to move in the appropriate direction. And then we need to, just like with our ball, set our center back to self.xPosition and self.yPosition. Okay. So that's updating. We can now draw our we can now update the position of our ball as it moves around the screen. We can make sure it bounces around the left, right, and top of the screen, and make sure that we never get stuck going 0, going 0x or 0y, so that it bounces back and forth in one direction. That would not be very fun. What else can we do in here before we start to draw this and see how things work? We can set up our reset here, so we can say self.velocity And what we'll do here is we'll do the exact same thing we did above in our constructor. We'll set it to a random integer between 2 and 4, and a random integer between -4 and 4. There we go. What else can we do? We can set it back to the center. Self.xPosition equals constants.screen width over 2, and self.yPosition equals constants. Oops, if I spelled that right, it would autocomplete. Constants.screen height divided by 2, and then set our center. Self.rect.center equals self.xPosition and self.yPosition. There we go. So now we have the ability to reset everything, to reset the ball, to reset everything as we do with the player. We update, we bounce it around. We can now go ahead and bring this into our main class here. So we'll say from game.ball import ball. And right here we will say self.ball equals new ball. And then inside of our allsprites.add, we can just do a comma and do self.ball. We can add it in there as well. Everything else, I believe, will just automatically make it draw. And let's go ahead and hit play. Let's see what happens. So if we draw this now, oh look. Oh, well that's boring. The ball just went off the bottom of the screen. That wasn't very useful at all, was it? Okay. Well, let's check to see if the ball's off the bottom of the screen. How are we going to do that? Inside of ball.py, let's add another function in here. And we're going to say, are we off the screen? And if we are, we're going to reset. So define is off screen. Oh, we don't need two selves in there. One self. And then what we'll do is return self.yPosition is greater than the screen height. So did we fall off the screen? If so, we need to handle this. Okay. How are we going to handle this? Inside of our update function of our main game class. So here we'll have our update, and before we do all of the sprite updates, we're going to check to see if the ball is off the screen. So at the top of the update function, we'll say if self.ball.is off screen, what are we going to do? We'll say self.player.lose life. Okay. So now we're going to start using that we're going to start keeping track of those lives. We already defined what lose life does. We know that it's going to subtract 1. We'll actually deal with that later, but for now, we're going to say lose life. Okay. And then we can say self.ball.reset, and that will move us back to the center of the screen. Okay. So now if I hit play with that little bit of function in there, oh, look at that. We're bouncing off the screens. We're bouncing off the edges. We're falling off the bottom. We're resetting to the middle. Okay. This is starting to look a lot more. But I don't know if you noticed, we went through the paddle. If I move the paddle around and try to catch this ball, oh, it goes right through it. Okay. That's because we're not actually checking collisions with the paddle itself. So how are we going to do that? All right. I'm glad you asked. We're going to add into the ball class here. We're going to check for collisions. So above the is off screen, we're going to add another function, another method here. We're going to say def check collide paddle. And then I'm going to pass in a reference to the paddle so that we can check it here. Okay. So if self.rect, and then we'll use the collide rect. So we're going to use our rectangle's collide rect function, and we'll pass in the rectangle of the paddle. So this tells us we've hit the paddle. All right, so we could just say, yes, we collided. But now we're actually going to deal with that collision. What are we going to say? We're going to respond based off of how the paddle hits and the direction that the paddle is moving. We're going to change the ball's velocity based off of that. So to do that, we'll use absolute value to check, did we hit the top of the paddle? Okay. So we'll say if ABS, and we'll say self.rect.bottom minus paddle.rect.top. What this is going to do is this is going to say if the bottom of the ball minus the top of the paddle, and we're going to take this, and now we're going to do a comparison. We're going to need another constant here, I believe. Yeah, let's go ahead and define another constant. In here, let's say we have a collision threshold, and we're going to set that to 12 pixels, just based off the size of everything we have. What this is going to allow us to do is, because the ball is moving at a good clip, it's moving at a good pace, we want to make sure that the ball hasn't moved beyond the top of the paddle. So we're going to give it a little bit of squishiness here. And that's what this collision threshold is we're going to say if we go over the top of it just a little bit in the update, we're going to count that as hitting the top of the paddle. So to do that, we have to say, did the actual ball minus the bottom of the ball minus the top of the paddle, is that less than constants dot collision threshold? And then is the velocity moving down? So is our y velocity greater than 0? So if we're moving down and we're at the top of we're above the paddle. Okay, so if we're moving down, the collision happened, and we're technically above the top of the paddle, then we're going to say that hit the top of the paddle. What we can do now is we can say self.velocity of y is just going to go in the opposite direction. Okay. So, what we're doing here is we're saying, based off of this, bounce upwards. Okay. We're also going to do a little bit of magic here. So self velocity 0. So we're going to take our x velocity and we're going to add it to that direction that I added to the paddle earlier. So if you remember, left is -1, right is +1. So if we moved left last, we're going to move, we're going to change our velocity to also swing towards the left. And we're going to change our velocity to swing towards the right if the paddle recently moved right. Okay. So we're going to make it go faster in the direction that we moved it. What that also means is that we can slow the ball down by moving in the opposite direction that the ball is moving. Okay. So we can now choose to speed up or slow down our x direction based off of how we're moving our paddle. Then what we need to do is we need to define a maximum ball speed. Because if we didn't define a maximum ball speed, you could theoretically get going really fast. So we don't want to do that. We don't want to go infinitely fast. We want to set a max ball speed. And we go from -4 to 4 as our starting speeds. So what we can do here is we can set our max ball speed to, let's say 5. We can go 1 over the current starting. All right. So let's do that. We'll set our max speed to there, and then we'll say, inside of here, if self.velocity of 0 is greater than constants.max ball speed, we want to set our self.velocity of 0 to that max ball speed. Okay, so we don't want to go faster. If it's greater than that, set it back down. And we have to do the opposite. If self.velocity of 0 is less than the negative of that ball speed, we're moving in the opposite direction too fast. And now what we're going to do is we're going to set this velocity 0 equals negative constants.max ball speed. Okay. And finally, if we're not hitting the top of the paddle, so if we detect a collision and it's not on top of it, we're going to assume it's on the side, just to make things easier. So we're going to set self.velocity of the x times equals -1. There we go. we're going to move the x velocity in the opposite direction. We assume we hit it from the side. So, sorry, that's going to knock the ball away from you, and it's going to fall off the bottom of the screen. Is there anything else we might need inside of here? Yes, when we get to adding the bricks, we're going to need a way of bouncing the ball in the opposite direction. But I can add that later. Let's go ahead and just see how this works before we get too far ahead of ourselves, okay? So we're going to move the paddle around now. We're going to check. And yeah, of course, I forgot to do something here. So I have this check collide paddle. I'm just not using it anywhere. So let's go ahead and use it, shall we? That would probably help here. So inside of our update function, we're going to go ahead and check for the collision, and if it happened, we'll react to it. So before we update the sprites, we'll add a little line here, self.ball.check collide paddle, and we'll pass in the paddle. Is it? Oh, it's player, not paddle. My bad. There we go. Self.player. So we'll pass in the player, which is the paddle, and we'll check for collisions. So now let's see what happens, shall we? All right, run it now. Oh, this is what I was talking about. It can bounce back and forth. Something's wrong with that logic then. If it's stuck bouncing back and forth, there's something wrong with the ball logic here that says if velocity is equal to 0. What did we miss? What did we miss? Oh, yeah, there it is right there. So if self.velocity of 1 is equal to 1. Nope, we want that to be equal to 0. All right, look at that. So if the y velocity is equal to 0, set it to 1. Okay, there we go. That should help. That should make this a little bit nicer. Oh, hey, look at that. Paddle's working now. And the ball isn't going to get stuck anymore. So, huge wins across the board. Okay, so we're actually almost done here. Now all we need to do is draw some bricks and have them get broken when we run into them. Okay? So let's close this and let's start that journey. Adding bricks is going to be a little bit more complicated. Okay? And the reason it's going to be a little more complicated is because we're going to have multiple rows of bricks. We're going to need to detect collisions with all of those. So let's go ahead and create in here, inside of our game class, we're going to create a new Python file, and we're going to call this bricks.py. Okay. Inside of here, we're going to import Pygame, and we're going to import our constants. So same as we've done everywhere else, let's bring those in. Then I'm going to define an array at the top of the class here. Okay, I'm going to go copy and paste something here. Feel free to pause. You're going to need time to put all this in, but I'm trying to get all of this done. So let's go ahead and make this pretty quick. So what I'm doing here is I'm saying assets/element blue rectangle.png, element blue, element green, element gray, purple, red, yellow. So I'm going to bring in all of these file names. I'm going to create an asset array up here. What this is going to allow us to do is to easily grab based off of what row we're drawing. We're going to draw 6 rows of these bricks. So I am going to define 6 different colors and have each of them show up in their own row. All right, that's what we're doing there. All right, hopefully you've paused and done all of that. And now let's go ahead and define 2 classes. So we're going to define a bricks class, and then we're going to define a singular brick. And a singular brick is going to inherit from Sprite. Okay, so we've got 2 different things happening here. The logic inside of here is going to be, oops, too many blank lines. Yeah, it's going to be quite simple compared to the other classes, because all this needs to do is draw the bricks on the screen and check to see, did something hit me, and if it did, kill me. All right? So let's start with drawing bricks themselves. We only need 1 function in here. Everything else is going to get taken care of by inheriting from Sprite. So let's go ahead and set up our dunder init, and then call super dunder init. And then we need to draw the brick. So we're going to say self.xposition. Oops. Autocomplete on things that don't exist yet. Self.xposition equals constants dot. Oh, we haven't defined it yet. Yeah. Okay. Let's go over to our constants real quick. Sorry. And we're going to have to define where we want our bricks to start drawing. We don't want them to draw off the left or the right or the top of the screen. So we're gonna bump our bricks. Oops, 5. We're gonna create a new line here, and we're gonna say brick start is equal to 16. So we're gonna move 16 pixels from the top and left of the screen, and run it all the way over so that there's 16 pixels left on the right side of the screen. Okay. We'll just give it a 16 pixel pad around the edges. All right. I chose that because it's divisible by the size of our screen and the actual size of our elements. So if I open up this blue rectangle here, you can see that it's 64 by 32, 64 pixels wide. So if you take 64 divided by our total screen width, 800, and then there's 32 pixels left over. And if we split that in half, that's 16 pixels on either side. Okay. Hopefully that math makes sense. You can play around with the numbers if you don't believe me, but that's what we're going to do. I'm also going to create a couple of other things here that we're going to use. We're going to set the number of columns we want. We want 12 columns. That's 64 pixels times 12. That'll bring us within our screen width. That's how many bricks we can fit across. And then the number of rows we're going to draw is going to be 6. So we'll do a 6 by 12 grid of tiles for us to be able to break in our wall. Okay? And that should be the last thing we need here. So inside of our brick class, now we're actually going to use this constants dot, and then we'll do the brick start. And now here's where things get a little bit fuzzy. We're going to take inside of our initialization, we're going to pass in what row and column. Okay? Oops, not M. There we go. We're going to pass in which row and column this brick is being instantiated in. And then what we can do is we can say our column times 64. And then we're going to shift it over halfway. We want it to be in the center, so 32 pixels. We're going to shift it since it's 64 wide. So the column where we're going to start drawing the brick is 16 pixels from the left, plus we're going to take what column we're in times 64 to determine the offset of the particular brick we're drawing based off of the column number. So 0 times 64 is 0. So if we drew the first one, it would be 16 plus 0 plus 32 to shift it over 32 pixels so that we're drawing it in the center. Okay? So there's that. And then our Y position is going to equal constants.brickstart as well. And we're going to now add our row times 32 pixels. Okay. And we're going to add 16 pixels since it's only 32 pixels tall. Okay. So there we go. That's how we're going to determine the X and Y position. We're going to use this little mathematical formula here. Okay. Then we need to load in our image. Our self.image is going to equal to pygame.image.load, and we're going to load from the bricks array based off of what row we're in. Okay. So this bricks array will start with row 0, 1, 2, 3, 4, 5. Okay. So based off of what row we're passing in, we'll go there. And then self.rect. The rest of this should look super familiar. Self.image.getRect. And finally, self.rect.center is going to equal self.xposition, self.yposition. There we go. And so this is it. This is all we need to actually draw each brick. We need to know where it is in the rows and columns. We'll use that to mathematically calculate where to actually draw the X and Y position, and we'll draw it. So that brings us up to the actual bricks class itself. So we'll do our dunder init here. We're also going to pass in, instead of just self, we're going to pass in our sprite group. And you'll see why in just a second. We're going to require our main sprite group to be passed in so that we can put each brick we create into that sprite group. Okay, and we don't have to go and do that from outside of the bricks class. So we're going to say all sprites is going to equal whatever was just passed in. Okay, so we'll set that here. And then we're going to set up a second group, all bricks. And we're going to set that to Pygame sprite group. Okay, so we're going to set up a second group. This is going to be important for determining collisions. Okay, let's initialize all of our bricks. For r in range, and we're going to say constants dot brick rows. So we're going to say for each r in the row array, and for c or column in range of constants dot brick calls. Okay, so we're going to do a double nested loop here to initialize each row, and in each row we're going to initialize each column. Okay, and then all we have to do is set brick is going to be a new brick with our column and row being passed in here. Oops, that's backwards. RC, our row and column. There we go. For each row and column, right? Row, column. Makes sense. All right. Then we need to add this so that it gets drawn. Self dot all sprites dot add that brick, and then self dot all bricks dot add the brick. There we go. So we've added the brick to two groups. Okay, let's look and see what this looks like. Let's hit play now. Let's make sure everything looks right. Oh, it doesn't look right because we haven't actually instantiated this bricks class. So let's go back here to our initialization and import this from game.bricks, import bricks. We want the plural bricks here. And then after all of the sprite initialization, we'll come in here and we'll create self.bricks is going to equal that bricks object, and we'll pass in the all sprites. There we go. Now let's update it and see what happens. No, still not calling it. Why not? Why? Oh why? Oh why? Oh why? Oh why? Oh why? I have to be missing something here. What am I missing? What am I missing? Bricks, range. Oh, yep, that'll do it. My autocomplete tricked me here. I didn't catch it. So when I add each brick, I have to add them into both groups. Sorry about that. We all make mistakes. So self.allSprites and self.allBricks. We have to make sure it shows up in both of those. Let's hit play. Now, hey, look at that. Now we have a whole bunch of bricks here being drawn to the screen. Fantastic. And that looks pretty good. I'm pretty happy with the way that came out with the colors lined up that way. Okay. So now we've drawn all the bricks to the screen. The only thing that's really left to do is to flesh out the game, to actually make the bricks explode when you hit them, and to keep track of lives, show the lives on the screen, maybe a game over screen, a couple of little things to kind of flesh out here, but we're coming up on the final stretch. So let's go ahead and get this knocked out. So I'm going to create a check collision inside of the bricks class, and I'm going to pass in the ball. Okay. This is going to allow me to go through that collision list, that list of bricks that I created as part of this class, and actually walk through the whole thing and see, did I collide with any of those? And we'll do that by creating a collision list, and we're going to set that equal to pygame.sprite.sprite collide. So we're going to check for sprite collisions, and we're going to do by ball and self.allBricks. So we're going to check for any collision with the bricks. And then the other thing we can do is we can do the auto kill on collision here. We don't want to do that. We're going to do that ourselves. Okay. Then what we can do is we can say for each brick in the collision list. So this collision list will come out with every brick in our all bricks that is colliding with the current ball. We're going to say ball dot bounce. So this is the bounce function that I was telling you we're going to create. We haven't done it yet, but it's here. And then we're going to say brick.kill. Okay, so we want the ball to bounce around based off of it hitting a brick. And we want the brick to die. And the kill function here, all it does is, for a sprite, it removes it from every sprite group that's drawing it. Okay, it removes all references to it, and eventually the garbage collector will come in and delete that brick itself. All right. Now, what we can do is inside of the ball, we can create our bounce function that I was telling you we were going to need to create. So here, after is off screen, we'll create a new bounce function. And this is going to be pretty simple. Self.velocity of 0 is going to equal negative self.velocity of 0. There we go. And self.velocity of 1 is going to be, let's set a random integer of -4 to 4. Okay. What this does is we're going to randomly bounce. Based off of us hitting that brick, we're going to change our x direction. We're going to flip the x direction. And then our y direction, we're going to randomize. We're either going to go up or down based off of our hit. Okay, so we could go through it, we could break through it, or we could bounce down in the opposite direction, and the speed will vary. Okay. This adds some randomization to the game. It makes it a little bit more playable and a little more fun when we actually have that collision. So now what we're going to do is we're going to use that check collisions from our bricks. So we now have check collisions. We've bounced the ball. We've defined that, and we have a kill. Now we need to actually check for the collision. So how do we do that? Pretty simple. In our update function in our main game class, we're going to come down here. Right after we check for colliding with the paddle, we're also going to check for self.bricks.check collisions, and we'll pass in the ball reference here. Okay, so we're going to check collisions with the ball. We're going to see, did things collide? Okay, now let's run this. Let's see what happens here. Okay, book. Oh, look at that. We're bouncing off. We're breaking some bricks. This looks great. This looks wonderful. Okay, so we're kind of bouncing around based off of the randomness. It makes it a little bit more playable. It makes it a little more enjoyable. We can see everything is working as we expect it to work. Okay, the other thing we're missing here is we're missing kind of an ability to show when we run out of lives, and we're missing the ability to reset everything when we do run out of lives. So let's add those. We'll take a couple minutes to do that, and then we'll have ourselves a full game here that we can play. So to show game over, what we're going to do is we're going to come up here into our main game class, and we're going to define right after our font here, we're going to say self.gameOver equals false. So we're going to say game's not over by default, right? That doesn't make sense. All right. And then inside of our update function, we're going to say here, if we're losing lives, if self.player.lives is less than or equal to 0, self.gameOver is going to equal true. Okay, so if we've lost all our lives, we're going to set game over to true. Then inside of our draw function, we're going to need to add some stuff in here. Okay. So let's go ahead, and we're not going to draw our sprites every single frame all the time. Instead, what we're going to do is we're going to say if self.gameOver, then we want to perform one action, and what that action is going to be is we're going to say we're going to set up some text, and we're going to use that font we uploaded above, and we're going to say self.font.render, and we're going to render game over. All right, and PyGame dot color. Let's set the color to white since we have a black background. So we'll set up the font. We'll say game over. We'll set this little flag, and then we'll draw everything to the screen. Self.screen.blit. The text we just drew. And then where are we going to draw this? I played around with the numbers here already, so this is going to be kind of some magic numbers. But we're going to set it to screen width over 2 minus 75. So based off of the size of the font, we want to be in the center minus 75 pixels so that we slide it to the left a little bit because of the game over text. Otherwise, we'll show off offset to the right a little ways. And then once we set that, we're going to set constants dot screen height over 2. So we're going to put it in the middle of the screen in the Y. Okay. Then we'll create our else, and this is where we'll actually update all of our sprites. And then the other thing we can do in here is take the lives that we have. We don't have any way of knowing how many lives do we have left. Let's add that in. So we'll set new text equals self.font.render, and we'll say lives, and we'll do a 0. We'll do an inline format here, and we'll say self.player.lives. So we'll grab the number of lives we have, we'll inject it into that string, and then we'll set pygame.color back to white. And finally, let's draw it on the screen. Text, and let's draw it at 15 by 15 pixels. Okay, I arbitrarily picked that. Play around with where you want that to draw. So when we run this now, you'll see, hey, look, we have our lives showing up here at the top. When we fall off the bottom of the screen, bam, lives 2, fall off the bottom of the screen, bam, lives 1, and fall off the screen, game over. So all of that looks great. That looks like it's working like we expect it to. But now that we're in game over, we have no way of resetting the game. We can add in that functionality now. As you saw, we were adding reset into all of these. So we have resets already here for pretty much everything, right? Except for the bricks. We'll see how to reset that in just a second. What we're going to do here is right before our handle events, we're going to add a new function, and we're going to call that reset. Okay, and what we'll do as a reset is we'll set game over to false. We'll set up a new player object. This way we reset the player to the center of the screen. We forget everything that we knew about the player. We have new lives, all of that. We'll reset the ball. Okay, and this will leave the old references to those objects dangling, and the garbage collector will come in and clean them up for us. And then we'll set self.allSprites, and we'll call empty on it. This will delete everything that was in there. Okay, and then we'll call self.allSprites.add, self.player, self.all. Okay, and then as the last thing we need to do is we'll set up a new bricks object, and we'll pass in the all sprites again. And so the only thing left to do is to tie this to an event. And I believe what we should do here is say inside of our handle events, we'll add a new if block here. So if self.game over, and we press pygame.k space, we press the space bar, we'll do self.reset. Self.reset. Okay. So there we go. We'll call reset in the case that the game's over and we press the spacebar. So let's go ahead and watch and see what that does. So everything falls off, and falls off. And now we're game over, and I hit the spacebar, and we reset. And that's it. So at this point, what I'm going to have you do is go off and add some improvements to this. You can add some particle effects to the exploding of the bricks. You can give the bricks individual lives. So make the bricks at the bottom harder to defeat than the ones at the top. Or a wide number of features that you can add here. You can add a score component so that bricks at the top are worth more points than bricks at the bottom. There's a lot of things you can do to now build upon this game, make it a lot more fun, but this is the basics of everything you need to know. So I hope you enjoyed today's tutorial. I hope you learned a lot about Pygame and the way that you can set up your project to be more professional, to be easier to work with, and to split it up into multiple files. So go out, enjoy, program your hearts out. And if you have any questions, make sure to leave a comment below in the box. And make sure that you subscribe to the channel if you like this. There will be plenty more tutorials in the future. Thank you all so much. I look forward to seeing you again.